All right, hey guys, today in this video, we are going to learn how to do some operations with radicals. So specifically, we're going to learn how to multiply, add, and subtract radicals. All right, so we're going to start with multiplying radicals, and I think this is the easiest one. So think back when we just learned how to simplify radicals. If I was having you simplify the square root of 50, remember I told you another way to write that was you could rewrite it as the square root of 25 times the square root of 2. That's kind of the same when you're multiplying radicals. So if I gave you the square root of 25 times the square root of 2, that's the same as you can multiply both of those radicands, or those numbers on the inside. So I can rewrite that as the square root of 25 times 2, or the square root of 50. Okay, so it's just another way to rewrite it. Okay, so if you look at this one, the square root of 3 times the square root of 5, you can rewrite that. That's the same as taking the square root of 3 times 5, which is the square root of 15. Now, you should always, once you get this far, you should always see if you can simplify that. Are there any perfect squares that divide into 15? I do not think there are, so that is simplified all the way. So that would be my final answer, square root of 15. I cannot simplify that down anymore. Okay, let's look at the next one. The square root of 18 times the square root of 2. Now that is the same as writing the square root of 18 times 2. So again, you can just multiply those radicands, or the numbers on the inside. Well, this 18 times 2 is the same as the square root of 36, and then we know the square root of 36 is 6, if I'm just taking the principal square root. So my final answer is just 6. Again, that's if I'm taking the principal square root of that. All right, let's take a look at our next one. So this one is multiplying. Now remember, there's really a little multiplication symbol here. When you multiply, it does not matter the order you multiply. 5 times 2, that's the same as 2 times 5. Those are both 10. Okay, so here I can multiply my 2 times my 3. Okay, and then I can multiply my radicals, 6 and 7, which is 42. Okay, so now when I do this, 2 times 3 is 6, and then I still have the square root of 42. Now you do need to see, can I simplify the square root of 42? Are there any perfect squares that divide into 42? There are no perfect squares that go into that, so I am all the way done, and this would be my final answer here. Okay, let's try one more quick one. So we have 4 square root of 20 times 3 square root of 2. Remember, you can multiply those. 4 times 3 is 12. And then I can multiply inside my square roots and rewrite that as 20 times 2, which is the same as 12 times the square root of 40. Okay, now square root of 40 I can break up. I know a perfect square that goes in there would be 4 times 10. Okay, so now the square root of 4 is actually 2, so I'm going to bring that out here. 12 times 2 times the square root of 10. And then finally, 12 times 2 is 24. And then I still have the square root of 10. I don't think there are any perfect squares that can go into that, so that would be my final answer, 24 times the square root of 10. All right, so let's have you try these 4 without my help. So I want you to pause the video and then push play when you're ready to correct them. All right, so here are the answers to these 4 problems. Take a look at them. You can pause the video and check out my work and see how you did on them. All right, now we're going to go into adding and subtracting radicals. So adding and subtracting radicals are actually just like adding and subtracting like terms. So you guys know like terms are like 5x and 3x. You can put those together by just adding the coefficient part. So 5x and 3x, that would give you 8x. Again, they have the same variable. That's kind of the same as radicals, and now I'll kind of show you why it works. So what if I asked you guys the square root of 25 plus the square root of 25? Okay, so you guys know just by working this out, the square root of 25 is 5, plus another 5 would end up giving you 10. Now let me show you how it works, treating them as like terms. So the square root of 25 plus the square root of 25. It's basically, I could put a little 1 outside here. 1 times, think of it, it still means multiply. 1 times square root of 25, same thing. I put a 1 here. So look at this. I have 1 of the square root of 25s plus another 1 of those. That is actually the same as saying I have 2 of the square root of 25. Now, let's see if this works out to give us the same answer. Well, the square root of 25 is actually 5. And then I still have times 2, which ends up giving me 10, which is the same thing I got over here. Okay, so just a quick refresher of what I just went over. When you are adding radicals, they have to have the same radicand, or the same number on the inside. So you guys might notice this is kind of like my like term, the square root of 25. I had 2 of them that I was adding, so I put a 2 square root of 25, and then I just kind of worked it out, and got my answer. Okay, let's take a look at another one. The 3 times the square root of 5 plus 10 square root of 5. So first thing I noticed is that they have the same radicand on the inside. So this is kind of like the like term. It's sort of like having an x there. So it's saying I have 3 of those plus 10 more of those. So total, you can just add this coefficient part. I have 13 square roots of 5. So my final answer is 13 times the square root of 5. Now, I can't simplify that because the square root of 5, there's no perfect squares that go into that. So that's as far as I can go. Now, if you want to check this, you could grab your calculator and actually type this in and type this in and see if you get the same as this. You will. Okay, let's try another one. What if I had 8 times the square root of 2 minus 5 times the square root of 2. So again, they have the same radicand inside here, okay? So this is the same, so I can actually just subtract them. So I can take 8, take away 5, I end up with 3 times the square root of 2. Okay, again, that's all the way simplified because I can't break the square root of 2 down. All right, if I gave you this one, I have the 3 times the square root of 8 plus square root of 8 plus square root of 8. Remember, this is really saying there's one of these and one of these as well. Okay, so they all have the same radical, so I can actually add these together. I have 3 of them plus 1 of them plus 1 of them, so that would be 5 times the square root of 8, and that would be my answer. But make sure you always check. I almost forgot to. I can actually break the square root of 8 down. I can break it down into 4 times 2, and then the square root of 4 is 2, so I'm going to bring that on the outside. And then I still have that square root of 2 on the inside. And then 5 times 2 is 10 times the square root of 2. This would be my final answer. So this is not simplified all the way. This is. All right, so you might be thinking, well, that's pretty easy if they have the same radicand on the inside. What if they have a different number on the inside? So look at these two, square root of 18 plus square root of 8. Okay, I want you to grab your calculator right now, and I want you to get what the square root of 18 is and what the square root of 8 is. Okay, so I just did it, and I got about 4.24, about 2.83, and then I rounded to about 7.07. So let's see if it works if I do this. What if, these are different radicals, but what if I did 18 plus 8? Okay, that would be 26, and then I'm going to type in square root of 26 on my calculator, and that actually equals, if I do that, 5.09, if I round a little bit. Okay, was that the same answer? It was not. These are not the same answers. So if they are different, you can't just add them together. That does not work. Okay, so please don't do that. You can always check if you're not sure. So now I'm going to show you how you can actually do this. All right, so in order to see if you can actually combine these, you have to try to simplify them first. So the square root of 18 is not simplified. I can break that down into 9 times 2. Because 9 is a perfect square, the square root of 9 is 3, so now I have 3 times the square root of 2. So that's all the way simplified. Square root of 8, I also can break that down into 4 times 2. All right, square root of 4 is 2, and then times the square root of 2. Now, look at my new problem that I have here. Hopefully you notice that now they have the same radicals. They both have square root of 2. Now I can add them together like they're like terms. So if I had 3 of them plus 2 of them, that's the same as 5 of the square roots of 2. This would be my final answer. All right, let's take a look at this one. Again, they do not have the same radicals, so I should always check and see, well, can I break it down a little bit more? Okay, well, 75, I know that a perfect square that goes in there is 25. So I'm going to break it down into 25 times 3. Now, the square root of 25 is actually 5. Got to bring that on the outside. And then I still have my square root of 3. 4 times 5 is 20. And then I have square root of 3 plus, now I have my square root of 3 over here. Now, remember, there's really a little 1 on the outside of here, right? Because 1 times the square root of 3, same thing. Now I can combine these. I have 20 of them plus 1 more would give me 21 times the square root of 3. This would be my final simplified answer. All right, let's try another one. So I have 3 plus the square root of 24 plus the square root of 54. So I'm going to see first if I can break down these square roots. So 24, I think 4 goes in there. 4 times 6, okay? Square root of 4 is 2, and then I have square root of 6 still. Okay, plus this 3 out here, plus 54. I think I can break that down to 9 times 6 is 54. Square root of 9 is 3, and then I still have square root of 6, which I can't break down anymore. So now, when you get this far, Some common mistakes I see people make are putting this 3 together with these things here, okay? The 3 does not have a square root symbol, so I'm just going to have to keep my final answer saying 3 plus these two I can combine because they are like terms. 2 of them plus 3 of them gives me 5 square root 6. So my final answer is just 3 plus 5 square root 6. Remember, this is not a like term with these other ones because there's no square root symbol here. So this would be my final answer. All right, why don't you guys write this one down, pause the video, and try it. This is kind of a difficult one, but I think you guys can do it. So push play when you're ready to see the solution. All right, so here is the solution to this one. Now, you might have done it a little bit different when you were breaking it down, but your final solution, hopefully you guys got to this point. You can't combine the square root of 22 with these other ones, so I can only combine this one, and then it was 6 minus the 8. So that is negative 2 square root 7, and then I still had my 2 square root of 22. All right, so just as a quick refresher, we learned today how to multiply radicals, and we learned that if you have 2 radicals, like the square root of a times the square root of k, you can actually multiply the 2 radicands, so a times k, and then take the square root of that. So that was the multiplying rule, and then the adding rule was if we had like 3 square root a plus 2 square root a. These are like terms, so you can basically just combine them and end up with 5 square root of a. So that is what we learned today. If you have questions, please reach out to your teacher.